Hi everybody, this is Shivakumar. Today we are going to discuss about work, energy and power. So here first we'll see work. Okay, so the basic definition of the work is that the product of force in the direction of displacement and the direction. So this is the basic definition of the work. So here I will try to write. Okay, so the work. The definition of the work is the product of force in the direction of displacement, in the direction of displacement and displacement. So here we can write this. So the basic definition of the work is that the product of force in the direction. You can write here the. So in the direction of the displacement and the directions and the displacement. So here we can write in the form of the formula F. Work is denoted by W. Okay, so W is equals to F dot S. So here you see we know that the force is what? Force is that it is a push or pull of an object to change the shape or size or its direction. So here we know that force is nothing but the product of mass and the acceleration. So we know this. The product of the change in the momentum, the change in the momentum of an object is directly proportional to the force which we have learned in Newton's laws. In Newton's second law. So Newton's second law says that the change in momentum is directly proportional to the force. So by that we got this formula F is equals to ma. So where F is the force, m is the mass, a is the acceleration. So here the SI units, the units of force is Newton, or we can also write kg meter per second square. Kg meter per second square. So we know that here we are also having the S. S is what? S is nothing but the displacement. So S is displacement. So the definition of this displacement is that it is the smallest distance between initial and the final positions. So S. So the units of this displacement is meters. So here we got the work done is the product of force in the direction of the displacement and the displacement. So here what happens? The units of work. What are the units of the work? That is nothing but here we are having force. So the unit of force is kg meter per second square. And here we are having displacement. So what is the SI units? What is the unit of the displacement? That is meters. So here what happens? This will be equals to kg meter square per second square. So the units of the work is kg meter square per second square. And we are also having this 1 kg, 1 meter square, 1 second square will be equals to 1 joule. So the unit of the work is also joule. Okay, or we can also take here this will be equals to the kg meter per second square is nothing but Newton. So the unit of the work is also equals to Newton meter. So the work done is that the product of the force in the direction of the displacement and the displacement. So here we can write this in the form of the formula W is equals to force into displacement. The units of the work done is equals to kg meter square per second square. The unit also equals to 1 joule, and we can also write Newton meter. So here kg meter per second square. So this is MKS. We need to convert this into CGS. So 1 kg is equals to how many grams? That is equals to 1000 grams. So we need to write 1000 grams. And meter square. Here we have to write meter square, right? So 1 kg meter square. So 1 meter is equals to how many centimeters? That is equals to 100 centimeters. So we need to write 100 centimeter into 100 centimeter. Why? Why? Because here we are writing meter square. So for that reason we need to write the centimeter into centimeter. That is equals to centimeter square. And second square. So 1 second is nothing but the second. So for that reason we need to write 1 second square. So here what happens? This will be equals to 1, 2, 3, 4, 5, 6, 7. So this will be equals to 10 to the power gram centimeter square per second square. Right? So here what happens? This will be equals to 10 to the power 7 grams centimeter square per second square. That will be equals to 1 kg meter square per second square. So we can write this also equals to 1 joules. We can also write 1 joule is equals to 10 to the power 7 gram meter square per second square. So we call this is also ERGS. ERGS. So here what happens? 1 joule is equals to 10 to the power 7 ergs. Okay, so ergs is CGS units and this joule is SI unit. And this joule is also can be written in the form of kg meter square per second square. That will be equals to the 10 to the power 7 gram centimeter square per second square. Okay, so we are having this work. This work is that here we are having force in the direction and the displacement. In the direction of the displacement and the displacement. So here what happens? This F is a vector quantity, force is a vector quantity, and displacement is also a vector quantity. So what happens? Is this a scalar quantity or vector quantity? It depends on that. It may be a vector quantity or scalar quantity. But here work done is a scalar quantity. Okay, work done is a scalar quantity. So here we are having dot product, right? Here we are having dot, right? So this is a dot product. So vector into vector dot product, that will gives the scalar quantity. The dot product of the two vectors gives a scalar quantity, right? So work done is a scalar quantity. Work done is a scalar quantity. So here this is having that. So here what happens? The product of force in the direction of displacement is there. So let us do here. Here we have taken a mass m. Okay, a mass m on a floor. So here what happens? A force is given in this direction. So let us take angle theta here. Okay. So this object is moved towards this. Okay, it moved here. Okay, this mass is moved in the displacement of S. Okay, so displacement is in this direction, right? So this is my force. A force is there here. So here what happens? The formula will be equals to the force is that is in the component of in the direction of the displacement. So displacement is in this direction. Okay, so this force should be in this direction. Okay, so the value of this will be equals to F cos theta. So here what happens? The work done will be equals to F cos theta dot S. So here what happens? The work done will be equals to F cos theta dot S. So you can also write this formula as W Fs cos theta. Fs cos theta. So this may be equals to W is equals to F dot S. Now we'll take a small mass, not small mass, a mass M. Okay, so let us take a small displacement. Okay, so this object is moved here, right? So it made a small displacement ds. Okay, so this object is moved. When we apply a force here, this object is moved a small displacement that is equals to ds. Now I would like to find out the work done here. So then what happens here when the force is constant? Here, when the force is constant, this object is moved towards the displacement ds. So I would like to find out the work done here. So then what happens? This dw. Why? Because it is a small work done. So the small work done is dw is equals to f dot ds. So I want the full work done. So then what happens? We need to integrate on both sides. So this will be equals to dw is equals to f dot s. We need to integrate on both sides. Then dw is equals to w will be equals to w is nothing but the work done will be equals to integration of f dot ds. So here what happens? The force is constant, but the displacement is changing. We need to take the limits here, initial limit and final limit here of the displacement for a small displacement. For a displacement, change in the displacement. So here what happens? The work done will be, the formula will be equals to, work done will be equals to integration of f dot ds. So initial displacement to the final displacement. So the work done will be equals to integration of f dot ds, where the limits of the displacement will be equals to si to sf. Initial displacement to the final displacement. Okay. So here we are discussing that this is work. So we are having three types of works. Okay, we are having three types of works. They are positive work, negative work, and zero work. So here what happens? You will see we are having three types of works. There are three types of works. They are, work is having three types. They are one, positive work, and two is negative work, and third one is zero work. Okay. Now we'll discuss these three works. Okay. Now we'll see the types of work. First one is positive work. So positive work. So here the definition of the positive work is the direction of force component is along the direction of the displacement. So the force component is along the direction of displacement. So here what happens? When we are applying some force to an object, right? So here what happens? The force component is along the direction of the displacement. Then we can say that is the positive work. So let us say here I would like to take a mass m. Okay. So here I am applying some force. So then what happens? This object is moving in this direction. Okay. So here what happens? This object moved here. That means the displacement took from here to here. So this is the direction of the displacement. So here I took ds. ds means what? A small displacement. So here what happens? To get to the positive work, first we need to take the force component. This is my force, right? The force component is always along the direction of the displacement. So here what happens? This is my force. Here we have to take the angle between the displacement and the force, that will be equals to f cos theta. So here what happens? F cos theta is the component of the force along the direction of the displacement. So f dot s. So this will be my work done. So here what happens? The work done will be equals to, the positive work done will be equals to the product of force component is along the direction of the displacement and the displacement. Okay. So here what happens? Here. So then what happens? The angle. So here what happens? If an object is moving in this direction, so the displacement is in this direction. So displacement is in this direction. So then what happens? Up to where the angle to be taken. That is that when an object is moving in this direction, that means the displacement. So up to 90 degrees. Up to 90 degrees, we can take the positive work. So here what happens? The angle will be equals to more than 0 degrees, equals to or more than 0 degrees and up to 90 degrees. So then what happens? The angle here we can take that the angle between the force component and the displacement must be less than 90 degrees. Must be less than 90 degrees. So the angle for the positive work bit is from 0 to 90 degrees. So the positive work, so 0 degrees, the angle should be greater than the 0 degrees and less than 90 degrees. Okay, so this is for positive work. So here what happens? The angle between the force component and the displacement should be less than 90 degrees. Okay, so coming to the negative work. Negative work. So here what happens? The force component is here in positive work. The force component is along with the direction of the displacement. But coming to the negative work, so here what happens? The force component here the force component is opposite direction to the displacement. So then what I mean here for negative work, the force component is opposite direction to the displacement. So then what happens here? The work done will be equals to the product of force in the force component is opposite to the direction. That means we are going to get F dot S cos theta. So here we are going to get negative direction. So this negative sign indicates the direction. So this is for the negative work and for this is for positive work. So then what happens? Here what happens when an object is applied some force. Okay, so the object moves opposite direction to the force. Okay, so then what happens in frictional force? So let us take the frictional force. So then what happens when here an object of mass m is given some external force, then if this object moves in this direction, okay, so this object is moves in this direction, so the displacement is in this direction. So for that the frictional force is in opposite direction to the displacement. So then what happens? This F will be equals to the opposite direction to the displacement. So for this we can take that. So here what happens? The force is having positive direction and displacement is in negative direction. We can take like that. Or force is in negative direction or displacement is in positive direction. We can take anything. Okay. So dW, W means the work done is equals to minus Fs cos theta. So here for negative work the angle is between 90 degrees to 180 degrees. So here what happens? The angle between 90 degrees to 180 degrees. So here what happens? The angle is more than 90 degrees or equals to or less than 180 degrees. Okay, if any force is applied between these angles, we may take that is the negative work. Okay, so here what we got? We got the positive work and negative work. Now coming to the zero work. So what is zero work? So here what happens? Let us say the third work is zero work. Zero work. So here what happens? Here in the positive work we got the force component is along with the direction. In negative work the force component is opposite direction. Then in zero work the force component is perpendicular to the displacement. So let us say, see here, so the angle between the force and the displacement should be equals to 90 degrees. Angle between the force and displacement should be equals to 90 degrees, then we can say that is zero work. Okay, we can take that one, or also we can take here. We know that the work done formula is F dot S, right? So any one of this, the force or displacement, it may be 0. That means, so if we are taking, so let us say this board is there, this board. So I would like to give some force towards this side. I am giving some force, but what happens? This board is not moving, not getting displaced. So for that reason we can say the displacement is 0. So here what happens? If I give some force also, this object is not moving. So for that reason we can say that the work done will be equals to 0 degrees here. Okay, so F dot S is equals to, so I would like to take S value, the displacement is 0. So 0 into something, 0. So we got the 0 one. Okay, so if may have the force is 0 but the displacement is there, then we can say that is also the 0 one. So how do we say? So here what happens? If this value of force is equals to 0, so the value of force is equals to 0, then we can say that 0 into something, that is equals to 0. So the work done is also equals to 0 here. So then what happens here? Any one of the component of force or displacement is 0, then we can say the product of these two gives the 0 work. Okay. Now we'll see a question. So here what happens? Let us take an object. So here I would like to take an object of mass m. So here I am considering it is Earth. So then what happens here? If I raise this object to the height at h, so here what happens? I just raising this object towards the height h from the surface. So what is the sign by the applied force and what is the sign by the gravitational force? So here what happens? I just applied my external force F here. So then what happened here? So then what happened? This object is moved towards the height h. So then what happens? The displacement. So the displacement is h here. Okay. So the applied force is towards up direction. So then what happens? The force here, the force is upside and the applied force, this is applied force. Okay, and the displacement is also along the force, along the applied force. Then what happened here? So the work done is positive or negative here. So then what happened here? The applied force and displacement both are in the same direction. So for that reason, we can say this is the positive work done. Okay, positive work done. So coming to the gravitational force. So we know that this object is moving upside. So then what happens? The displacement is upside. And now the gravitational force is always downwards. That is equals to mg. So then what happened here? So the gravitational force mg is downwards and the displacement is upside. So then what happens? This will be equals to negative work done. Negative work done. So then what happened here? So the angle between the gravitational force and the displacement is equals to 180 degrees. Well, you guys see here, so the displacement is along this direction and the gravitational force is along downwards direction. So the angle between these two will be equals to 180 degrees. So we know that the formula, that is that the work done is equals to force into displacement cos theta. So then what happens? The force, let us take F. Okay, displacement is h. So then what happened here? Here the force, the gravitational force mg and S is h. Okay, and the cos theta, we know that cos 180 degrees will be equals to -1. So how do we know? So this is the graph of the cos theta. So this is cos 0 is equals to +1 and cos this will be equals to pi by 2. Pi by 2 is 0 and this is pi, that is equals to -1. So for that reason we can say cos 180 degrees is equals to -1. We can take the work done is equals to -mgh. So here what happens? This work done is negative work done. Okay, coming to the pendulum. Let us take a pendulum here. Okay, so this pendulum is moved towards here. Okay, making an angle theta. Okay, so here what happens? This object at this point, the displacement along this direction, right? the displacement is along this direction. So then what happens when an object is here? Okay, so this object moves towards this side. Then what happens? The displacement is along the tangent, right? So then what happens? The displacement is along this direction, and the force, this is tension force. So then what happens here? Tension is perpendicular to the displacement. Let us take the small displacement. Okay, so tension is perpendicular to the displacement. So then what happened here? The work done by the tension force is equals to 0. So the work done by tension force is equals to 0. Why? Because the tension is perpendicular to the displacement. So for that reason, we can say this work done is equals to 0 work. Okay, 0 work. So coming to the work done in resolved form. So where do we find these resolved forms? So work done. So resolved form is that when the object is in the form of x, y, z axes. So work done by resolved form. So resolved form. So here we can take an object, any object. So here what happening? A force F is applying here. Okay. So the displacement is along this direction. So let us take S. So the angle between these two will be equals to theta degrees. The angle between these two, force and displacement is S is theta. S is my displacement, F is my force. So we have to write this force in resolved form, and the displacement is also in the form of resolved. So here what happens? The force F is equals to Fx I cap plus Fy j cap plus Fz k cap. And coming to the displacement, that will be equals to S is equals to Sx I cap plus Sy j cap plus Sy Sz k cap. So here what happens? The work done. What is the work done? We know that F dot S. So here what happens? In dot product, here I only will get a multiply. So we know that I cap dot I cap is equals to 1, j cap dot j cap is equals to 1, k cap dot k cap is equals to 1. Except this. So if I take I dot j is equals to 0, j dot k is equals to 0. Okay, so for that reason we are going to multiply that the work done will be equals to force into displacement. W is equals to F dot S, that will be equals to Fx Sx plus Fy Sy plus Fz Sz. So this is the work done in the resolved form. Okay, let us take an example. So let us take a force. So a force F that is equals to 2 I cap plus 3 j cap plus 2 k cap is applying on a body from a point A that is equals to 1, 2, 1 to B that is equals to, here I would like to take 3, 4, 3. Okay, so then what happening? An object is applied by the force of 2 I cap plus 3 j cap plus 2 k cap from 1, 2, 1 to 3, 4, 3. So here what happens? The force is given in the direction. The force is given directly. Now we need to find out the displacement. So what is displacement here? Here we know that the displacement S is equals to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay, so here this will be equals to x2 y2 z2 x1 y1 z1. So then what happens? S will be equals to 3 minus 1 2 I cap plus here 4 minus 2 that is equals to 2 j cap. Here minus 3 minus 1 that is also equals to 2 k cap. So here what happening? S is equals to the displacement that is equals to 2 I cap plus 2 j cap plus 2 k cap. So then what happens here? We know that what is the total work done here? That is nothing but the force into the displacement. So F dot S. So here what happens? This 2 I cap plus 3 j cap plus 2 k cap dot product of the displacement that is equals to 2 I cap plus 2 j cap plus 2 k cap. So here what happens? For the dot product you need to multiply x components at once, y components at once, z components at once. So here what happens? The work done will be equals to 2 into 2 that is equals to 4, 3 into 2 that is equals to 6 plus 2 into 2 that is equals to 4. So the work done will be equals to the 14 joules. So when a force 2 I cap plus 3 j cap plus 2 k cap is applied to the body from 1 comma 2 comma 1 to 3 comma 4 comma 3, then we are going to use the work done will be equals to 14 joules. So this 14 joules will be written in the form of 14 Newton meter or 14 kg meter square per second square. Okay, or we can also write in the form of 14 into 10 to the power 7 ergs. Okay.